We started page 9 last class, but we're kind of picking up where we left off. Okay, we were talking about the mole and how a mole is a new unit of counting. So last class we talked about like a pair is 2 things, a dozen is 12 things. Well, now we're talking about the mole, which is 6.02 times 10 to the 23rd things. And we talked last class about how if we have 1 mole of puppies, that's 6.02 times 10 to the 23rd puppies. That's a pile of puppies the size of the moon. It's a lot of puppies, okay? But if we have 2 moles of sodium atoms, that's twice as many atoms, 1.204 times 10 to the 24th, Abby, is what we would get when we multiply that out. With atoms, because atoms are so small, having 1 mole of puppies is the size of the moon. Having 2 moles of sodium atoms, that would still be small enough to fit in your hand. And that's because atoms are just so tiny that having 1.2 times 10 to the 24th of them, that's like 12 sextillion, okay, that's a lot. Having this many of them, it would still fit in your hand. It's so small. Serena, please put your phone down. Then in example 3, we said if you have 6.02 times 10 to the 23rd kittens, how many moles of kittens is that? That's 1 mole. And again, that's a pile of kittens about the size of the moon. And then example 4 says how many moles of magnesium are in 1.806 times 10 to the 24th atoms of magnesium. There's a specific way we're going to answer this question. Here's what we're going to do. Okay, first we're going to draw a fraction times a fraction. Go ahead and draw a fraction times a fraction. What do you mean any fraction? We're just drawing bars for it is what I meant. Sorry if I was misleading. Okay, and on the bottom of the first fraction, just stick a 1 in there. On the bottom of the first fraction, just kind of throw a 1 in there. Now on top of the first fraction, we're going to take this number that they gave us and the word atoms, and we're going to copy that in. 1.806 times 10 to the 24th atoms. Just copy it straight in. Exactly the number they gave us. 1.806 times 10 to the 24th atoms. Just copy it straight in.
Do we have to write atoms?
Yes. Okay? Then, any word that's on top of this fraction needs to go to the bottom diagonal, so we're also going to write the word atoms down here. Any word on top of the first fraction also has to go on the bottom of the next one, so we're just moving it down the diagonal. And then on top of the second fraction, we're going to switch from atoms to moles because they're asking us about moles. So we're going to put MOL, that's our abbreviation of moles. Yes, it's an abbreviation that's only 1 letter shorter. Oh well, deal with it. Okay, now I have a question. How many atoms are in 1 mole? What have we talked about? How many of a thing are in 1 mole of it? It's this new number we just learned, 602 sextillion, or 6.02 times 10 to the 23rd. So we're going to write that 1 mole has 6.02 times 10 to the 23rd atoms in it. And now that we have 2 fractions filled out, you should know, because we just took a quiz over it, you should know how to solve these 2 fractions, how to multiply stuff out. So go ahead and do it. Put it in your calculator. If you multiply straight across, top times top, for your new top number, you're going to get 1.806 times 10 to the 24th. If you multiply straight across bottom times bottom, you're going to get 6.02 times 10 to the 23rd, because anything times 1 is itself. And then what do we do to simplify this? Before you round it. What do you do to simplify it? You can't just leave this as your answer. Divide it. Yeah, divide it. That's what I wanted. Divide it. When you divide this, your calculator should give you a nice pretty number, 3. If you put that in your calculator right, the answer is just 3. 3 what? Moles. Yeah, they were asking us to find moles. So 3 moles. 3 moles of what? What was the problem talking about? Magnesium. Mg, magnesium. So here's our answer. Okay? What we just did, drawing these fractions, filling out the fractions, writing the fractions, I know that's like brand new territory for you. I'm about to teach you a way that's going to make it really easy, and that's what the colors are for. Okay? So the colors are going to make it so you can do this math without it being so scary looking. Okay? We're just going to make it pretty instead. Don't you like pretty things? I love pretty things.
The diamond's pretty, but it doesn't make it any less hard.
Andy, why are you raining on my parade? Okay.
No, it's because basically saying it's like making it pretty, you want to make it scary, but it's still a hard math problem. And diamonds are pretty, but they're still hard. So,
Andy, we're moving on. Turn the page. Turn the page. Okay. What we're going to do to make this math a little less scary looking and a little more obvious is we're going to color code. So the first thing we're going to color code is the word moles. Anytime on this entire page you see the word mole, I want you to color the word mole green. It has to be green. I know some of you are sharing colors, but it has to be green. You cannot swap colors. Mole has to be green. Anytime you see the word mole, color it green. Molar is the adjective form, so I guess you could color molar as well. I'm not going to. You can. That's fine. Anytime you see the word mole on this whole page, and remember MOL is an abbreviation for mole. Anytime you see the word mole, you're going to color it green.
What about molar?
No, I made that. This is for me to take to the testing box later.
What'd she say?
No, he's in our
oh,
fourth
yeah, I
grade.
gotta ask.
Oh, yeah, yeah.
No, I
So it's like, I see how she's today too.
Yeah. Okay, we got all the greens? We're good? We're ready?
Wait.
Wait for what?
And for the people who are sharing to catch up.
Okay. Our next color is going to be blue. And blue is going to be atoms. Anytime you see the word atoms, you're going to color that blue. So like here.
Is atomic?
Atomic, sure, if you want to.
What about,
I'm only going to do atoms. But-
a friend of mine named Adam?
That's spelled differently, Andy, and I suspect you knew that.
What if like a
That's what
science
comes out the
lover,
robot.
like a science lover named their son Adam with a T? Would you do that?
Would I do that?
We love teaching science so much.
I would probably not do that, no.
She'd name him like magnesium.
No.
Yeah. If I eventually have kids, I'll consider your suggestions. Thank you.
Superman.
Okay. For now, blue is only going to be atoms, but in the future, we will find it is also particles and molecules, so we can color those blue too. For now, we're only going to worry about atoms being blue, but in the future, we will learn that we can make these other words blue also, so you can color those two right there blue for now. Oh, and I missed some.
Particles and molecules.
Particles and molecules, yeah. Okay, and we have one color left,
Grams for yellow.
and we are going to make yellow be grams. Grams are golden grams, like the cereal. So we're going to use yellow is going to be our grams. Lowercase g is abbreviation for grams. So you can color anything that's just a G. You can color yellow also.
I just made green.
Whoops. Okay. Abby, are you asking me a question?
Yeah.
Okay, can you say it louder for me?
We only have 5 grams.
I see 1, 2, 3, 4, 5, 6, 7, 8, 9.
What?
7, 8. Right.
I get 6.
Did you get the chart too?
Yeah.
And are you getting all the lowercase g's that are the abbreviations?
Yeah. Oh, nope.
Okay, so let's look at some patterns. If you look at this chart with these fractions, just look at just these 4 fractions right here. What do you notice about the colors? Right now we're only looking at these fractions and at the colors. What do you notice? Are there any patterns you see? Serena?
Like on the bottom,
Uh-huh.
the atoms is with the X10 to the whatever.
Yeah, okay. Blue is going with this 6.02 times 10 to the 23rd number. Yes, that is a definite pattern. I want to come back to that. You're right. I'm not ready for that. I will come back to that. What other patterns do you see?
Mole is in all of them.
Green mole is in all of them. Okay, we always need green. We always need moles. What else do you see, Olivia?
It's always next to one mole. It's like not one, it's other than.
Green is always one mole. It's always one mole. Okay, good. What other color things do you notice? Do you notice anything about the way that colors are paired up in the fractions?
There's at least one yellow and one green.
Can you rephrase that? I'm not sure I understand what you mean.
One mole with one gram.
Like if there's a green and a yellow, they're together? Okay. Can you generalize that some more? I want you to keep building on what you're saying. Because you're right, but there's more I'm getting to. Or can someone take what Abby said?
Because there's blue and green. And blue and green.
Okay, so we have yellow and green together, and we have blue and green together. What do you not see together?
Yellow and blue.
Yellow and blue. Okay. So, I'm going to synthesize everything that you guys just said, because you pointed out pretty much all of my points. We're going to write ourselves some notes at the bottom here. So put a little star. Okay, every two-color fraction, needs green. Every two-color fraction needs green. That's part of what Abby pointed out. And blue and yellow can never go together. Blue and yellow can never go together. I guarantee if you make a fraction that has blue and yellow in the same fraction, I guarantee it's wrong. I guarantee it. Blue and yellow can never go together. Okay, and the other thing you're going to see is that there will never ever be a fraction that is green over green for this unit. You're always going to need green with yellow or green with blue. You can't have green with green for now.
So will you be able to have yellow with yellow and blue with blue?
No. In fact, yeah, I guess you could say never the same color on top and on bottom. So never green over green or blue over blue or yellow over yellow. That's a good point, Abby. Thank you. Okay, and then what Olivia pointed out, that green is always one mole. And oh, hey, we wrote the word mole. What color should we color mole?
Blue.
What?
Green.
Yeah, there you go. Okay, and what Serena pointed out, I'm ready for it now. What Serena pointed out, that blue is always 6.02 times 10 to the 23rd. It rhymes. Blue is 6.02 times 10 to the 23rd. It stops rhyming when you finish the number, but it rhymes a little bit. What?
See what you wrote? You said green is always one mole, and mole is green.
Yeah, that's true. Good catch. Okay, blue is always 6.02 times 10 to the 23rd. Green is always one mole. And then we didn't really get to a rule about the number that goes with yellow. Look at the yellows up here in these fractions. What is this number? 12.01. Where did it come from? If you look at the rest of the page, where did they get 12.01 from?
Top of it.
That is the atomic mass of carbon. Guess what? The atomic mass on the periodic table is also called the molar mass. That means that's how many grams are in 1 mole. So if I take 1 mole of carbon, if I count a bunch of carbon atoms, if I count like here's 1, here's 2, here's 3, here's 4, here's 5, and I count a whole bunch of carbon until I get to 6.02 times 10 to the 23rd, and I take that pile of carbon atoms, there's going to be in the pile 6.02 times 10 to the 23rd of them, and I put the pile on a scale, that pile is going to weigh 12.01 grams. Because that atomic mass on the periodic table is also how many grams there are for 1 mole. So this number from the periodic table is also kind of a yellow gram number. So if I have 12.01 grams of carbon, since that's the number on the periodic table, I know that is also 1 mole of carbon, and I know that that is also this many atoms. If I counted each atom in the pile of 12.01 grams of carbon, I would have 6.02 times 10 to the 23rd atoms. So if you took some like pencil lead, did you guys know pencil lead is pure carbon? Yeah? If you took some pencil lead and you put a bunch on a scale until it weighed 12.01, then you would know that you had this many atoms of carbon sitting on top of your scale. This is how we count atoms.
So does that mean, grams will always be the atomic mass?
Yes, that means that yellow, grams, is always going to be the atomic mass from the periodic table. That is exactly what that means, Serena. Good job. Yellow is always going to be, grams are always going to be from your periodic table. When you're done writing that, I'm going to look at the next page. Can I move my paper yet, or are you still writing? We're still writing?
You can do it now.
I can do it now. Anyone besides Abby need me to keep the page? She's done. Is anyone else still going? We're good? Okay. So, let's consider the element titanium. Yes, and this is the titanium from the periodic table. They've got 47.90 here. And that means this is how many grams are equal to 1 mole of titanium, ladies. Ladies. That's how many grams there are in 1 mole of titanium. I'm familiar with it, yes.
If she watched Pitch Perfect, she's familiar with it.
I did watch Pitch Perfect.
I'll let number 2.
Okay. We're going to end up, when we do these problems, where they're giving us some color and asking us to change it to another color, we're going to end up with 2 fractions every time. We're always going to multiply 2 fractions. And every time, the bottom of the first fraction is going to have just a 1 there. No colors, no words, just a number 1. Every single time. You could do that all the way down the page if you wanted to. Every single time it's going to start like that. Every single time. I guarantee it. It's going to start like that. You could do that all the way down the page if you wanted to. Jesus.
Avogadro? Who's Avogadro?
It says you're going home.
I'm called
I'm gonna call 51266.
Now, just like that problem with the fractions we did earlier, we're going to find that whatever number they gave us is going to go in a certain place, and we're going to find that there's certain ways we have to fill out these fractions. But first, it'll be easier if we color the question. So do you see any words in the question that we can color that have a color that go with them? What? Grams? What color is grams supposed to be? Yellow. Golden grams. Golden grams. It's supposed to be yellow.
Titanium, isn't that yellow?
Okay. Titanium is, like in real life, is usually kind of a gray, silvery color.
4.6.
But then moles is green. Moles is green. So those are our 2 colors here.
But it says 4.47.9.
Are you looking at a different problem?
No, never mind.
Did you answer your own question?
Sort of.
Okay. Would you like to ask me your question?
No, it's stupid.
Are you sure? Okay. Feel free to ask me if you change your mind. Okay. Every single time, you'll draw your 2 fractions, you'll put a 1 on the bottom, you'll color the question. Then, whatever number they gave you is always going to go on top. with its color, always. 4.6 is the number they gave me, and it's green, so I'm going to put that on top.
I'll see you tomorrow. Don't worry about it.
Okay? Then, we take the number they gave us, we put it on top, we take its color, we put it on top, and then this is the kind of tricky part where you have to think about what you're doing. The color that's on top here, the color is also going to move down the diagonal. Just the color, not the number, just the color. So since there was green up here, we need to move green to the bottom down here. And because green is moles, we're going to label it moles as well. Okay, just the color. Don't move the number. Only the color moves. Only the color moves.
Oh, crud.
Only the color moves, not the number, just the color. Okay, and before we finish this problem, I want to show you a secret. Are you ready for a secret? You don't think you're ready for this, Jelly? All right. Look at page 9 where we drew this fraction here. Okay, and what if you color these fractions? Can you color these real fast? What color is atoms supposed to be? Blue, so we're going to color the atoms. And what color is moles supposed to be? Green, so we're going to color those. Okay. Here's a secret. Are you ready for a secret? You can only use each color twice. Do you see we have blue 2 times? And we have green 2 times? That's it. You can only use each color twice. And you have to use each other exactly 2 times. Each color has to be used exactly 2 times. If you use a color only once, I guarantee something's wrong. If you use a color 3 times, I guarantee something is wrong. You can only use the color twice, and you've got to use it 2 times. If you use it at all, you got to use it a second time, or I guarantee something's wrong. So, keeping that secret in mind, and we can even write the secret down. We can even write the secret down. Each color only gets used twice. If we write that secret down, and then use that secret on number 1, can I change the page or the screen? Yeah? Okay. How many times have I used green in my fractions right now? Twice. I can't use it anymore. What color do you think I should switch to?
Yellow.
Why do you think I should switch to yellow?
Because it's in the problem.
It's my other color and the problem. So on top of this lonely fraction that doesn't have anything on top of it, I'm going to put yellow. And yellow is grams, golden grams. So I'm going to write grams in. And now that I have some colors in here, I need to also figure out numbers. What did we say is our number that always goes with green? With green? We wrote that green is always 1 mole. So next to moles, we're going to put a 1. And what did we write about yellow? What did we do for a number next to yellow? It's from the periodic table. Now for this problem, they printed the periodic table on here for us about titanium. So what is my number from the periodic table that's going to go next to grams here? 47.90. How do we solve these fractions? Multiply straight across. So go ahead and put that in your calculator. Okay, I have a problem. What's the problem? There's no grams. I need to use yellow twice, and right now I've only got it once. Where's the second place that I should put grams? Yellow.
A whole plane.
How about next to your answer?
Oh.
Put it next to your answer. Now I've got green twice, now I've got yellow twice. That's a good indicator my problem is probably correct and done. Now I know you have questions. Are there, I am going to do more examples with you. Are there any questions you want to ask me before we do another example? Like how did I know this or how did I know that? Or where did this come from or where did that come from? What questions do you have so far? None? Are you guys all ballers and you already know how to do this?
I'm stuck.
I know, Olivia. I know. I'm like the whitest lady ever. Okay. Should I move on to the next problem? Are you ready?
I'm ready.
Okay, we start every problem as a fraction times a fraction, and we put 1 on the bottom. What else do I need to do before I do anything else with the math or with writing in the fractions? What should I do before that?
Color code.
Color code. So, I did hear someone say moles. What color should moles be? Green. And what's the other color in number 2? Blue. What word is blue? Atoms. Okay. What is my first step? What's the first thing I do? What?
Put atom. Put
The number of atoms. Where does it go?
on top of the.
On top of the 1. Brianna is correct. That number they gave us and its color, the other Brianna.
That's bullying.
The number they gave us and its color go on top over the 1. Okay? Now it's the tricky step. What do we do next?
Put the wall.
Your color that's on top
It needs to be one.
moves to the diagonal.
One atom.
Just, no, don't put numbers yet. No numbers, just colors. Just colors.
I know. I put all wrong one.
The blue that's up here also needs to come down on the diagonal. And that means atoms need to come down here. Not the number. No numbers yet. No numbers yet. Just colors. How many times have I used blue now? Twice. Can I keep using blue?
No.
No. What do I switch to?
Green.
Green. Switch to green. So what's going to go on top of my last fraction? What goes on top here? What color goes on top here? Green. And what word goes with green? Moles. Now I have all my colors and I'm ready to pick numbers. So we go look at our little star section. What number is supposed to go with green? Green is always 1 mole. And what number is supposed to go with atoms? Blue? Blue is always 6.02 times 10 to the 23rd. Blue is always 6.02. Blue is always 6.02. When it's blue, use 6.02 times 10 to the 23rd. So if you were jumping the gun and putting some numbers in here and you put 1 atom, you would have had a problem. Blue is always 6.02. How do you solve these fractions? What are you going to do? Multiply straight across and then divide. So 4.5 times 10 to the 24th times 1 is itself. 1 times 6.02 times 10 to the 23rd is itself. And then we do divide. When you divide those, you're going to get this in your calculator. How do you round this? How are we supposed to round? To the hundredths place. So instead of 7.4750833056, what am I supposed to write? 7.48. Yes. And again, I have a problem. I used blue twice. I only used green once. Where should my second green go?
The answer.
The answer. In your answer after the number. Yes. Oh, I forgot to box this earlier. Okay. I have a challenge for you.
Dun, dun, dun.
I have a challenge.
I failed.
I'm going to give you 1 minute to get as far as you can get on number 3. I don't expect you to be able to solve it by yourself. If you can't solve it all the way, that's okay. I just want you to see how far you can get. So you have 1 minute. See how far you can get on number 3. It's okay if you can't finish it. I just want you to prove to yourself how far you can get. Go quick.
The math system enhances.
I see a lot of you have mostly finished the problem. That's cool. You have about 20 more seconds to see how far you can get.
The number they give you is always going to be here. So this is well, let's do one piece at a time. 105.2%. What color is green?
I remember when we were at the scene, someone asked you about that, you were like, why did you?
I didn't order the whole. Just like white. I was like, all right.
Oh, titanium upstairs. You're welcome.
All right. Let's see how you did. What is the first thing? I drew my fractions. I wrote over 1. What is the next step that I do? Before I even write in the fractions, what should I do? Highlight. Even before you write anything else, highlight. So what color are moles supposed to be? Green. And what's the other color I use in this problem? Yellow. What's supposed to be yellow? The G, grams. Golden grams. Okay, then, and I saw some people miss this step and they ended up doing the whole problem backwards. I saw about 5 people do this. So careful about this first step. Whatever number they give you, that's what goes on top of the first fraction. That's the first thing you do, is take the number they gave you and its color and put it first. The number they gave you and its color go first.
You got mole problems. I just noticed that. Ouch, it hurts.
Andy, sweetie.
Okay, then, and here's the tricky part. Once you know what's up here, this is what's going to tell you what to write on the bottom. So, what goes on the bottom of my next fraction?
Grams.
Grams. Whatever color's on top, it also goes on the diagonal. Always. Whatever color's on top, that also goes on the diagonal. So if you end up putting yellow here, you have to put yellow down here as well. Now, how many times have I used yellow? Twice. Can I keep using yellow? No. What should I switch to? Green, moles. So I'm gonna put green on top, and I'm gonna put moles in there. Okay, what number is supposed to go next to moles? 1. A 1, always. 1 mole. Green is always gonna be 1. And where do I get a number of grams from? Where does yellow come from? Grams. Periodic table, which they wrote it for me up here for this problem. That is your mass from the periodic table. Grams, mass, yellow, those come from the periodic table. To solve this problem, now that my fractions are filled out, I can multiply straight across. 105.2 times 1 is 105.2. 1 times 47.90 is 47.90. And I can't write a fraction as my final answer, so how do I fix this fraction? What do I do? Logan, what do I do to get my final answer? Divide them, yes. So 105.2 over 47.90. And my calculator gives me this. Let me zoom in so you can see it better. How am I going to round that? If I'm supposed to round to the hundredths place and it's 2.196, how do I round this? 2.20. If it's 19.6, the 6 rounds the 19 up to a 20. So this is going to be 2.20. I'm missing a color. Where do I put my second green? On the answer. Moles are also part of my answer. Okay. Do you have any questions before I have you try some all the way the rest of the page without me? Serena. So it'll be like whatever color you need the second one. So like you already used green twice, and you'd only use yellow once. So yellow. Okay, go to your stamp page. Go to your stamp page. Today's the 28th. And you're going to get a stamp for finishing page 11. I am going to check it to make sure it's right before I stamp it. And Miss Lacasio, she will make sure it is right before she stamps it. Okay, I'm going to put up a timer that's just for when the bell's going to ring so that you know. And we'll be coming around to take a